Good day everyone, I am Marinol Redarlin de la Cruz, together with my groupmates Brian Himskirksey Alano, Jambi M. Buklati, Jerry Arverson Zigalo, Kino Andre Lenciano, John Ergino Olion, and Leila Piromero will report about steel. So first, what is a steel? Steel is an alloy of iron with typically a few percent of carbon to improve its strength and fracture resistance compared to iron. So sinasabi na ang steel ay alloy daw ng iron combined with carbon. So ginagawa ito para ma-strengthen yung steel and maging fracture resistance compared dun sa iron mismo. So, ang alloy ay isang metal made by combining two or more metallic elements. So, yung two metallic elements dito ay yung iron at carbon. Pero hindi lang naman siya iron at carbon din. Meron ding ibang elements na kinombine and madidiscuss ito later on. Many other elements may be present or added. So, ayun nga. Hindi lang yung iron at carbon, may iba rin na pwede i-add. The stainless steels that are corrosion and oxidation resistant need typically an additional 11% of chromium. So, doon daw sa stainless steel ay, bigyan ko lang kayo ng idea, ito ay isang type ng steel. Pero mamaya palalawakin pa yan, doon natin i-discuss. So, ayan, kailangan daw ng 11% of chromium. Bakit? Kasi dito ay nagiging corrosion and oxidation resistant yung stainless. Stainless steels, alam ko naman na familiar na kayo dito and kalimitan natin ito nakikita. So, bakit ba kailangan corrosion and oxidation resistant? Siyempre, gagamit ka ba ng steel na madaling kalawangin? So, diba hindi? Kaya, ayun. Kailangan siya dagdagan ng chromium para hindi siya kaagad masira. Ngayon naman ay i-discuss ko ang composition of steel. Diba nabanggit kanina na ito ay alloy ng iron at carbon. Pero hindi lang talaga siya carbon lang at iron. Steel is an alloy of iron and carbon containing less than 2% carbon and 1% manganese and small amounts of silicon, phosphorus, sulfur, and oxygen. So, ayan, hindi lang iron and carbon. Meron ding manganese, silicon, phosphorus, sulfur, and oxygen. Ito sa example, dito sa picture, ito ay composition ng carbon steel. Makikita na may majority ay iron, pero meron ding few percent of carbon, manganese, silicon, phosphorus, sulfur, pwede rin chromium, nickel, molybdenum, and copper. So, sa carbon steel lang yan. Since iba't iba yung type ng steel na i-discuss mamaya, malalaman din natin kung ano yung iba pang composition ng steel. Steel is the world's most important engineering and construction material. So, ayan, sinasabi ng steel daw ay isa sa pinaka-importanteng ginagamit sa engineering and construction. Kasi yung steel ay kalimitan na makikita sa mga beams, sa mga railings, diba? Tapos sa mga iba't iba nating mga gamit kaya sa lababo, mga lagay natin ng tubig, yung parang thermos, ganun. So, ayun, ito yung composition of steel. So, ito pa, dagdag. It is used in every aspect of our lives, in cars and construction products, refrigerators and washing machine, cargo ships, and surgical scalpels. Ayan, makikita natin sa picture, ito yung sa structure, ginagamit siya sa mga beam, diba, and columns. Tapos dito naman sa baba yung bolts and nuts. Alam ko naman talaga na sobrang familiar tayo sa steel, ang dami natin siyang nagagamit. So, the main reason for the popularity of steel are the relatively low cost of making, forming and processing it, the abundance of its two raw materials, yun nga iron ore and scrap, and its unparalleled range of mechanical properties. So, before tayo pumunta sa iba pang mga subtopics, i-discuss ko muna ang history of steel. The history of steel can be traced back to the emergence of iron, the main component of steel. So, ito nagsimula yung history nito sa emergence ng iron na ito nga ang component of steel. There are findings that suggest that iron was used 4000 BC. Their use was likely more limited. In the beginnings of metalwork, bronze was significantly more popular than iron. Archaeological discoveries prove that bronze was widely used for weaponry and armor, but it also had commercial uses. Sinasabi na around 4000 BC ay ginagamit na ang steel, ngunit limitado lamang ang gamit dahil siyempre di pa naman alam noon ng tao kung paano ito kukunin at kulang pa ang kanilang kaalaman kung paano ito gagamitin. Sa pagsisimula ng metalwork ay mas popular ang bronze. So, ito yung panahon pa ng Bronze Age, hindi pa tayo dumadako sa Iron Age. So, yung bronze ay ginagamit din for weaponry para sila ay mabuhay sa pang-araw-araw, magagamit sa pagka-hunt and sa iba't iba pang uses. Meron din itong commercial uses. Pero after naman ng ilang panahon, ay mas naging kilala ang iron and ito yung tinatawag na Iron Age. So, ito na nga, katulad ng sinasabi ko kanina, ay dumating na yung Iron Age. It is around 2700 BC. Around 2700 BC, more and more iron findings were discovered. So, ayan, dahil unti-unti nang didiscover yung iron, na naging ito na yung dahilan upang tawagin yung period na yun na Iron Age. Steel itself is an alloy made of at least two elements, iron and carbon, and it emerged around 2000 years into the Iron Age. Ito makikita sa picture yung bato. So, ito yung batong to ay hindi lang basta bato. Ito ang oldest steel type known, which is meteoritic ion, or pwede rin tawagin na meteoric ion. So, meteoritic ion is the oldest steel type known. Iron was extracted from iron-nickel alloy found in very few meteorites. So, ayan, kailangan pa pala makakita ng meteorites. So, yung meteorite pala yung ginamit para dun sa oldest steel type known. Therefore, the use of meteoritic ion was very rare and reserved for special occasions, ornaments, and ceremonies. So, dahil nga mahirap hanapin yung meteoritic ion, since galing nga to sa mga meteorites, sobrang hirap makahanap ng malaking meteorites. So, maliliit lang talaga siya, kaya siguro sobrang rare niya. And noon ng panahon, dahil rare, ito ay reserved sa mga espesyal na okasyon. As long as 4000 BC, ancient Egypt has used meteoritic iron for ornaments and spear tips. Even earlier, around 5000 BC, beads made from meteoritic iron were used in Iran, proving that steel has a long-standing and diverse history. So, ayan, noon daw sa ancient Egypt, 4000 BC pa lang ginagamit na tong iron sa mga ornament and spear tips. Tapos, before pa pala, 5000 BC, ginamit na rin tong meteoritic iron sa Iran. Continue natin yung discussion, dun pa rin tayo sa Iron Age. So, ayan nga, iron replaced bronze because of its superior hardness, which was particularly important in weaponry and tools. So, mali yung akala natin kaya iron age kasi wala ng bronze, sobrang dami ng iron. Hindi lang siya basta-basta sa amount nakabase. Dahil din ito sa kanilang gamit. Diba noon, uso pa yung mga naghahunt ng animals para sa kanilang pagkain and tools para sa mga pag-uukit nila or other task pa. Kailangan nila ng mas hard na bagay. So, ayun, dahil yung iron ay superior kaysa sa bronze in terms of hardness, ito ay naging way para magkaroon ng iron age. Bukod hindi lang dahil sa parami yung amount na nakikita. While iron can be found aplenty on Earth, it rarely appears as a minimal because its deposit can be primarily found in ore and meteorites. So, ayun na, minimal pa din yung deposit since yung deposit ay makikita lamang sa ore and meteorites. Yung meteorites ay yung maliliit lang, wala ka talaga makikita yung sobrang laki na meteorite. So, kaya ayun, rare pa rin siya. So, over time, nagkaroon ng steel making processes dahil nga may nakikita ng mga deposit ng iron and yung knowledge ng tao ay nagka-advance. So, ayan, ito yung wood steel na nakikita niyo sa picture. So, siyang parang kutsilyo na galing sa nagawa sa steel. So, in antiquity, steel was produced in foundries and cubicles, two types of ancient furnaces made for smelting iron. Wood steel is one of the oldest manufactured steel known and has its roots in South India. So, ito daw, wood steel ay oldest manufactured steel from South India. Ito ay high carbon steel that is known for its toughness and sharpness. So, diba kanina, steel lang talaga yung ginagamit. Ngayon, ito ay high carbon steel na. So, ibig sabihin, meron na siyang carbon na naihalo. In fact, Damascus steel, which is one of the most used steel types for blade to distill, is made with wood steel. So, yung Damascus steel ay gawa din dito sa wood steel. So, around 400 BC naman, the Chinese already had quench hardened steel, which steel making process demands rapid cooling of the material that results in a hard surface layer. So, ito naman, around 200 BC, the Chinese melted wrought iron along with cast iron to obtain a carbon intermediate steel. So, ayan, pagdating ng 400 and 200 BC, may iba't iba na paraan para makapag-produce ng steel, especially ang Chinese. Meron na itong iba't ibang process and syempre, iba't iba rin ang gamit. So, over time, may iba't ibang improvements na nagkaganap dahil nga nagkakaroon ng iba't ibang knowledge ang mga tao and kung ano-ano na rin ang discover nila. So, around 19th century, nagkaroon na ng modern steel making. Hindi na yung katulad kanina yung mga nabanggit. Steel making has made significant changes, making steel even more economical and attainable for multi-purposes. So, ayan nga, dahil nga marami ng pagbabagong naganap, meron ng iba't ibang paraan kung saan yung steel making ay naging economical and attainable for multi-purposes. Furthermore, these evolutions and more varieties of steel types and iron and alloy steels. So, ayan, Hanggang ngayon naman, nagkakaroon pa rin ng iba't ibang changes, pero yan, starting the 19th century, nagkaroon na ng more modern steel making. Iba't iba na yung gamit niya. Hindi na yung tool dati, nasa weaponry lang and tools. Yan, nagamit na rin yan sa mga paggawa ng mga bahay-bahay pa. And hanggang ngayon, nag-i-improve pa rin siya. At magkaroon na ng iba't ibang klaseng steel types. Yung steel types ay di-discuss yan later. So, for the next part of this report, here is Kino Denciano.
Good day everyone. I'm Kino Andre Eslenciano and I'm going to discuss to you the first two types of steel, the carbon steel and alloy steel. First, we start at the carbon steel. All steel contains carbon, but carbon steel is unique for a notable absence of other elements in its makeup. Though it only contains 2% carbon or less by weight, its elemental nature makes carbon steel a strong, durable material that is ideal for numerous uses. As the percentage of the carbon in steel increases, they also increase in proportional stress, ultimate tensile stress, hardness, wear resistance, and strength. Simultaneously, as this amount of carbon increases, there is a decrease in ductility, permeability, malleability, and weldability. As the percentage of the carbon in steel changes, the mechanical properties also changes. Carbon steel is sometimes confused with cast iron, though it must contain less than 2% carbon. Cast iron contains 2% to 3.5% carbon, giving it a rough texture and more brittle nature. So, as the carbon percentage is on the 2%, we can only perform casting process. We cannot put the steel in the machine or do any kind of permeability, machinability, and we cannot cut the steel easily and convert it to wires. We also cannot carry out the ductility. The percentage of the carbon controls the mechanical properties of the steel and cast iron. Even though carbon steel is composed of alloyed materials, it doesn't have alloy classification because of the lack of other alloying elements in its composition. This simplicity contributes to carbon steel's popularity. It accounts for about 90% of all steel production. Let's proceed to the types of carbon steel. The first type is the low carbon. This is the most common and the least expensive type. It is easy to form due to its high ductility, good malleability, and high toughness. The chemical composition of the carbon is 0.006 up to 0.3%. This steel is very soft and show good amount of percentage elimination. However, these steels are not suitable for heat treatment. We can only do cold working as this steel is having less strength compared to the medium and high carbon steel. Now about its application based on its chemical composition. The carbon percentage is in 0.02 up to 0.10%, then the steel is suitable for manufacturing of wires, nails, rivets, boiler plates, and steel tubes. And if the carbon percentage is in the range of 0.1 to 0.2%, then the steel is suitable for manufacturing bolts, camshaft, and connecting rods. And the last is if the percentage is in 0.2 to up to 0.3%, then the particular steel is suitable for manufacturing steel parts such as H section, B section, and etc. The next type is the medium carbon. A carbon content between 0.31% and 0.6%. gives this variety a higher strength and lower ductility than lower carbon varieties. Medium carbons are found in gears and railroad tracks. This carbon can carry out both heat treatment and cold treatment to improve the strength. Medium carbon typically has alloys like chromium, nickel, and molybdenum added in order to increase stress resistance, perfect for creating items such as studs, gears that will encounter a lot of wear and tear. If additional hardening is needed, medium carbon steel can be heated and held until it reaches a uniform temperature, then soaked and cooled. And then, we will now proceed to its application. If the carbon percentage is in 0.31 to 0.4%, it can be used to manufacture the machinery parts, heat treatment, bolts, and nuts. And if the percentage is in 0.4 to 0.5%, then it will be suitable to manufacture the actual bolts and other stuffs for studs. And when the percentage is in 0.5 to 0.6%, it will be suitable for manufacture the hardened gears and dies. Last type of carbon steel is high carbon. This is the toughest variety and is more than 0.61% carbon and is often used to produce brick nails and sharp cutting tools like trencher blades. They do not contain more than 2% carbon. This is the strongest and hardest carbon steels and can carry out heat treatment. Heat treatments can make high carbon steel very hard but also brittle, which means that other measures need to be taken to prevent cracking. Chromium and manganese alloys can be added to high carbon steel while it's being formed to help the material avoid corrosion. It's also an ideal type of steel to subject to heat treatment in order to increase its hardness. High carbon steel is mostly used in hardened and tempered conditions. This steel shows high wear resistance that it can be put into a machines and can only carry out casting process. And in terms of its application based on its chemical content, if the carbon percentage is in 0.6 to 0.8%, then it can be used to manufacture range, bandsaw, medium-low tools, agricultural tools, and springs. And if the percentage is in 0.8 to 1%, then it can be used to manufacture dies, cutting blades, and drills. Then, if the percentage is in 1 to 1.2% of the carbon, then it is suitable to use to manufacture ball bearings and milling cutters. And lastly, if its percentage is in 1.2 to 1.4%, then it will be suitable to manufacture boring bars and mining tools and tools used in strong crushing plates. Carbon steel's relative adaptability and low cost make it an ideal choice for a variety of construction projects, both large and small scale. And before we go to the next types of steel, I want to show you a video on how you can easily determine the carbon content of a steel.
In this video, I'll show you an easy way to determine the carbon content of steel by observing the spark profiles. Alright, let's take a look at low carbon steel. Now medium carbon steel. And high carbon steel. Low carbon steel generally produces long fine sparks with little to no forks or sprigs. Steel that has a higher carbon content will produce more forks and sprigs. Here you'll notice that not only are there more forks and sprigs, but the stream is also shorter. You can use this technique to find out which of your parts would benefit the most from the case hardening method used in my last video.
Now, let's proceed to the second type of steel, the alloy steel. The alloy type is iron fused with one of several other elements, each contributing its own unique attributes to the final product. When other elements comprising metals and nonmetals are added to carbon steel, alloy steel is formed. These alloy steels display various environmental, chemical, and physical properties that can vary with elements used to alloy. It is true that all steels are alloys, but carbon and chromium are specific alloys with names attributed to the type of metal they form. Some of the elements that combine with iron and carbon to produce alloys are also found in tool steels, such as cobalt, tungsten, and molybdenum. For example, are ultra-hard metals that are designed for their impact resistance and cutting abilities. Now, I will show you a video on how alloy steel is made. There are hundreds of products that can be manufactured with alloy steels of varying compositions. These include alloy steel pipes and tubes, alloy steel plates, sheets and coils, alloy steel bars, rods and wires, alloy steel forge fittings, alloy steel butt weld fittings, alloy steel flange, fasteners, and more. Alloy steels have many uses in various industries, such as automobiles, mining, machinery and equipment, railways, roads, construction, buildings, appliances, and offshore applications. In the building and construction industry, alloy steels are used for very large modern structures such as airports, bridges, skyscrapers, stadiums in the form of a steel. Alloy steels provide the required high strength to support such large structures. Even concrete structures use alloy steels as reinforcement to add strength and reduce the overall weight of the structures. Smaller items such as screws, nails, and bolts made of alloy steels are used in the buildings and construction industry. Now, let's proceed to the types of alloy steel. Like what I've said a while ago, alloy steel is the combination of carbon, iron, and some elements. Some of these elements are aluminum, copper, manganese, molybdenum, silicon, and vanadium. Let's talk about first the aluminum. Aluminum elements can rid steel of phosphorus, sulfur, and oxygen. It can produce a lightweight, heat-resistant steel that's ductile and easy to work with. This type is often used in hot exhaust systems and power generators. The next one is the copper. Copper element can increase corrosion resistance and hardness. It can produce a corrosion-resistant steel that conducts heat very efficiently, making it a great choice for electrical wiring and industrial heat exchangers. The next element is the manganese. Manganese can increase high temperature strength, wear resistance, ductility, and hardenability. It can produce a impact-resistant steel that's extremely tough, that it can be found in bulletproof cabinets, anti-drill plates, and high-strength safes. Next one is the molybdenum. Molybdenum element increases strength and improves resistance to shock and heat. It can produce a weldable corrosion-resistant steel that performs under high pressure, making it well suited for underwater construction or oil and gas pipelines. Next one is the silicon. Silicon element can increase magnetism and strength. It can produce a soft-natured steel that's malleable and highly magnetic, and creates a strong permanent magnets that are used in electrical transformers. The last one is the vanadium. Vanadium element can increase corrosion, shock resistance, strength, and toughness. High impacts It can produce a high impact steel that's shock absorbent and vibration resistant and often found in automotive parts like springs and shocks. Other alloying elements that provide varied properties include bismuth, cobalt, titanium, selenium, tellurium, lead, boron, sulfur, nitrogen, zirconium, and niobium. These alloying elements can be used singly or in various combinations depending on the properties desired. Their downright versatility makes alloys a common occurrence in many construction projects. Copper and aluminum alloys varieties are particularly popular for their low weight and heat working properties. That's the end of discussion about the first two types of steels, which are the carbon steel and alloy steel. And to continue the discussion about the two more types of steel, here is Mr. John R.G. Maulyon.
Good day, I am John A. Maulyon, and I am here to report the remaining types of steel, which are stainless steel and tool steel. First is stainless steel. It is commonly known for its role in manufacturing medical equipment and appliances, but its range of use is far greater than just the gas range in your kitchen. Chromium is the alloy that sets stainless steel apart, lending the material its distinctive luster. Higher chromium content directly translates to a higher gloss when polished and has greater resistance to corrosion. Yung stainless steel po, yan yung makikita nyo na ano ba, yung mga bike or kung ano man pong equipments, sikat na sikat po yung material na stainless steel, which is yung hindi po siya kaagad-agad na kakalawang. At yung chromium alloy, yun po yung responsible para sa pagkakaroon ng polish na itsura at resistance sa corrosion. Next is types of stainless steels. First is Martensitic Alloys. Toughness is a hallmark of Martensitic alloys, but they are prone to corrosion. They are formed by a rapid cooling process that makes them ideal for heat treatment and are found in medical instrument, cutlery, and pliers. Martensitic stainless steels can be high or low carbon steels built around the composition of iron, 12% up to 17% chromium, carbon from 0.10% up to 1.2%. Up to about 0.% carbon, they are used mostly for their mechanical properties, for materials such as pumps, valves, and shafts. For about above 0.4%, they are used mostly for their wear resistance, and for tools such as cutlery, surgical blades, plastic injection molds, and nozzles. Martensitic alloys are hardenable by heat treatment, specifically by quenching and stress relieving, or by quenching and tempering. The alloy composition and high cooling rate of quenching enable the formation of martensite. Untempered martensite is low in toughness and therefore brittle. Tempered martensite gives steel good hardness and high toughness, used largely for medical tools such as scalpels, razors, and internal clamps. Next is ferritic alloys. These are less expensive steels with low amounts of carbon and nickel. Automotive applications are common final destinations for ferritic alloys because of their chromium-induced strength and sheen. Ferritic stainless steel is really defined as a straight chromium non-hardenable class of stainless alloys, which have chromium ranging from 10.5% to 30% and a carbon level under 0.2%. These steels are essentially non-hardenable by heat treatment and only slightly hardenable by cold rolling. Next, austenitic alloys. Austenitic alloys have higher chromium and nickel contents, improving their resistance to corrosion and causing them to become non-magnetic. They are present in commercial kitchen appliances and are popular because they are durable and easy to clean. Its primary crystalline structure is austenite, commonly known as face-centered cubic, and it prevents steels from being hardenable by heat treatment and makes them essentially non-magnetic. This structure is achieved by adding enough austenite stabilizing elements such as nickel, manganese, and nitrogen. Next is duplex alloys. A combination of austenitic and ferritic alloys results in a duplex alloy that inherits the properties of both while doubling strength. They are also ductile and corrosion resistant due to their fairly high chromium content. The main differences in composition when compared with an austenitic stainless steel is that the duplex steels have a higher chromium content of 20 to 28%, higher molybdenum up to 5%, lower nickel up to 9%, and 0.05 to 0.50% nitrogen. Both the low nickel content and the high strength, which enables the intersection to be used, give significant cost benefits. They are therefore used extensively in the offshore oil and gas industry for pipework systems, manifolds, risers, and in the petrochemical industry in the form of pipelines and pressure vessels. Next is another type of steel, which is tool steel. Tool steels are upfront about their business. They are used to tool manufacturing machinery. Tempering, the process of adding high heat, cooling quickly, then heating again, creates tool steel that's extremely hard and heat resistant. They are usually used in high impact environments and are very abrasive. Well, different types of tools requires different types of tool steel in production. Tool steel is used in a variety of ways to best serve the production requirements of a particular tool. Added elements will determine which particular application that it is suited for. First type of tool steel is air hardening. The high chromium content in this steel allows it to be exposed to high temperatures without distorting. These steels are hardened by air cooling. The carbon content is about 1% with manganese, chromium, molybdenum as the main alloying elements with sometimes addition of tungsten. These elements impart high wear resistance and induce high hardenability to confer air hardening properties to steels resulting in negligible dimensional changes during hardening. Next is water hardening. This steel is water quenched during use. It's the most affordable tooling type and is used to make common tools. These tool steels are essentially plain carbon tool steels. Carbon varies from 0.6 to 1.4%, and thus are the least expensive. These steels have low inherent hardenability. Section less than about 8 millimeters in thickness will true harden in water. Next, oil hardening. This oil-quenched steel is exceptionally wear resistant from slipping and is used to produce knives and shears. These steels contain high carbon with reasonable manganese content with occasional low alloy additions of chromium and molybdenum to improve hardness, hardenability, and wear resistance. These steels are relatively inexpensive. These steels possess very good non-distorting properties and are less likely to bend, twist, sag, distort, or crack during heat treatment as compared to water hardening steels. This steel group has best machinability of the cold work steel group, enabling them to obtain complicated shapes by machining to high degree of precision such as required for reamers, taps, blanking and forging dies, gauges, and stamping dies. Next is high speed. High speed steel is highly abrasive and impact resistant. It's found in drill bits and power saws. High-speed steels are highly alloyed tool steels developed initially to do high-speed metal cutting, and that's where the name is derived. Next, hot working. The name gives it away, but this steel can withstand extreme heat and is used in forging and casting. These tool steels are used mainly for high-temperature metal forming operations, such as hot stamping, piercing, hot forging, hot drawing, hot extrusion, upsetting, swagging, die casting dies of aluminum and copper alloys, and hot pressing dies for copper alloys, where the operating temperature is above 200 degrees Celsius and 800 degrees Celsius. Next is shock-resisting tool steels. Small amounts of carbon, silicon, and molybdenum harden the steel and suit it for punches and riveting tools. The primary characteristics of these tool steels are high toughness and ability to bear repeated impacts. Thus, the carbon content of these steels are intentionally kept low between 0.45% to 0.60%. But then, these steels have moderate wear resistance. The main alloying elements added are silicon, chromium, and tungsten. Silicon strengthens ferrite, but its higher content tends to accelerate decarburization, necessitating suitable precautions to be taken to avoid this during heating. These types can be further separated by the industry they're used in, as well as their hardness and toughness. Now, here is Ms. Leila Romero to report about different properties of steel.
Good day. My name is Leila Romero from BSCE 31 and I'm here to present properties of steel. Yeah, so properties is about qualities and characteristics. So this part is about qualities and characteristics of steel. So first is tensile strength. So the tensile strength is the amount of stress that a substance can take before becoming structurally deformed. The tensile strength of steel is comparatively high, making it high resistant to fracture or breakage, which is a key point in its use in infrastructure building. So yung tensile strength, so ang sinasabi dito na yung steel daw ay nakakapag-take ng malaking amount ng stress. So, highly ginagamit talaga yung steel dahil nga nakakapag-resist siya ng mga fractures or breakage. Kung yun nga, mataas yung kanyang tensile strength. Ayan, so sa next, ayan, so dito sa example or dito pinag-compare yung mga materials, pinag-compare yung kanilang tensile strength. So, kung makikita natin, yung steel ay may 180. So, isa siya dun sa mga may matataas. At kung mapapansin din natin, yung ibang mga materials na nakalagay dito, yung stainless steel din yung sunod, low alloy ferritic steel, ayan, halos puro steel, ayan. At sila ay may mga matataas na um, tensile strength. So, masasabi talaga natin na good choice yung steel para kung iko-konsidera yung tensile strength. So, good choice yung steel. So, next naman ay yung yan. So, next property is ductility. One of the useful mechanical properties of steel is its ability to change shape on the application of force to it without resulting in a fracture. It enables steel to be used in the making of different shapes and structure ranging from thin wires or large automotive parts and panel. So, dito sa ductility, ayan, yung ductility ay ability ng material para mabago yung shape at nang hindi nasisira agad. So, ito nga, merong ability yung steel na mabago yung shape niya, pero hindi malulus yung kanyang strength. So, ayun, napakahalaga nun sa isang material. Yun. So, yung steel daw ay meron ding mataas na ductility. So, isang trivia lang din. Sa Nepal, ayan, ang Nepal ay isang earthquake prone. So, ang ginagamit nilang mga materials sa kanilang building or structure ay tinatawag na ductile steel. So, ginagamit nila yon para kapag nagka-earthquake ulit, hindi talaga agad-agad masisira yung um, yung pinaka-building nila or yung structure nila since yung steel nga ay merong characteristic na ductile which is kahit na mabago yung shape niya, eh hindi agad siya magbe-break. So, yun. Next naman ay yung, yan, malleability. Malleability is closely linked with ductility and allows steel to be deformed under compression. It allows this alloy to be compressed into sheets of variable thicknesses often created by hammering or rolling. So, itong malleability at saka ductility, halos magkaparehas lang sila. Kasi mabago yung shape nung material. Ang pinagkaiba lang talaga nila, yung ductility, mababago yung shape niya kapag nag-apply ng force. Ito namang malleability, madedeform or mababago nga yung kanyang shape ng material under compression. So, compression yung ginagamit niya. So, yung under compression, makakabuo tayo sa steel ng mga sheets. Ayan, kung mapapansin nga din natin, meron tayo sa mga construction sites yung mga um, sheets ng steel. So, yun, isang property ng steel ay yung malleability. Ayan, para mag-allow na ma-deform yung steel under compression. Next is, ayan, durability. Durability. The hardness of this alloy is high, reflecting its ability to resist strain. It is a long, lasting, and greatly resistant to external wear and tear. Hence, it is considered a very durable material. Ito nga sa durability naman. So, first, ano muna yung durability? So, yung durability ay ability ng material na magtagal ng hindi agad-agad nasisira. So, yung steel ay meron ding mataas na durability. Sinabi nga dyan na very durable na material ang steel. So, ano nga ba yung importansya ng pagiging durable ng isang material? So, ang importansya niya ay syempre para magtagal yung paggamit ng steel at makakatulong din siya sa environment to conserve the resources at mare-reduce yung waste. So, masasabi natin na sa paggamit natin ng steel, mare-reduce natin yung waste at makakatulong din siya sa environment para makonserve yung resources. So, yun. Since ang steel ay durable, so, ganun din yung magiging benefits din niya. Ayun nga, magiging benefits niya sa environment natin. Yan, next naman ay yung conductivity. So, sa conductivity, steel is a good conductor of heat and electricity. These properties make it good choice for making domestic cookware as well as electrical wiring. So, yung conductivity naman ang ibig sabihin niya ay yung ability ng material na mag-conduct ng electric current. So, sinasabi nga dyan na ang steel ay nagko-conduct ng electricity at inaalaw nito yung mga electrons to move between atoms. So yun nga, yung conductivity ay nakakatulong para yung conductivity ng steel ay nakakatulong para yun nga, mas gamitin yun, maging good choice yung steel para sa isa mga cookware at mga electrical wiring para gamitin doon sa mga ganong part ng construction. So, ang next natin na property ay luster. One of the physical properties of steel is its attractive outer appearance. It is silvery in color with a shiny lustrous outer surface. So, yun nga, kung mapapansin din naman natin, yung steel ay maganda yung itsura niya talaga. So, kapag siya ay natatamaan ng ilaw, 'di ba? Napaka-shiny niya. So, ang ibig sabihin pala ng luster ay ningning in Tagalog. So, ang luster, in English, ito yung description niya, describes how light is reflected on the surface. So, yun, ang steel ay may physical property ng pagiging luster or attractive nga yung outer appearance niya. Next, ito nga yung isang example na masasabi natin na yung steel ay maganda yung appearance sa labas. So, dito sa dalawang structure na nasa picture, gumamit sila ng steel dyan. So, kung makikita natin, pwede rin talagang gamitin yung steel for aesthetic. At magiging good choice siya, hindi lang siya sa aesthetic, kundi maging sa strength din niya, ganyan. So, talagang nakakatulong yung steel. At maganda nga, hindi maganda siya sa mga strength, ganyan. At maganda rin yung kanyang um, physical appearance or yung physical property din niya ay maganda. So, next naman ay yung rust resistance. So, sa rust resistance, the addition of certain elements makes some types of steel resistant to rust. Stainless steel, for instance, contains nickel, molybdenum, and chromium, which improve its ability to resist rust. So, yung steel daw ay merong qualities at characteristic na rust resistance. Kaya nga siya palaging ginagamit sa construction talaga. So, dito, sinabi din dito na yung importansya din na ang material ay rust resistant. So, yung mga benefits na sasabihin ko ay mga benefits din ng steel dahil nga siya ay rust resistant. So, may extend ang equipment service life ng material. Of course, kung hindi agad-agad masisira yung isang material, mas magiging mahaba yung service niya, yung life service niya. So, next naman ay yung reduce repair cost. So, since hindi nga siya agad-agad masisira, ayan, hindi mo siya i-repair at yun nga, mas hindi siya costly sa mga owner, ganyan. So, next is can prevent operation malfunctions. So, yun, since hindi nga agad siya nasisira at siya ay rust resistance, so, hindi agad siya magre-react sa tubig since kung ano natin dito sa Philippines ay dalawa lang yung season, 'di ba? So isa ay maulan. So yun nga magiging magandang choice talaga yung steel for construction for the building. Yun nga kasi nga hindi agad-agad siya nasisira at avoid environmental issues since hindi nga agad siya nakasira. So hindi siya makakaapekto ng malaki sa environment natin. So, dito, ang mga properties ng steel ay tensile strength, ductility, malleability, durability, conductivity, luster, and rust resistance. Ayan yung mga good qualities at characteristic ng steel na inexplain para maging good choice talaga yung steel for
construction. So I will be presenting a video explaining also the good qualities and characteristics of steel. And for further explanation about steel.
Some of the essential uses of steel are in the construction industry. Pre-engineered steel design for buildings has many advantages over materials like wood. Lumber prices have increased 80%, and there are shortages across Canada. Ready to learn more about the perks of using pre-engineered steel buildings? Keep watching, as we've rounded up 5 of the primary benefits of this alloy. Long-lasting and durable. Pre-engineered steel buildings will last indefinitely with proper maintenance to prevent corrosion. That means that pre-engineered steel buildings will last your lifetime. One reason behind steel's longevity is its impressive dimensional stability. It has a much higher strength to weight ratio compared to wood. It isn't prone to warping, nor will steel creep, split, expand, or contract due to moisture. Bug resistant. Termites are among the world's most destructive pests, and they're all over Canada. As you might have guessed, these insects feed mostly on wood and organic materials. And yes, they're the same materials often used to support the weight and bear the wind, snow, seismic, and live loads any Canadian building experiences. Termites aren't your only enemy though. The same goes for woodworm, beetles, and sawflies. If these pests find their way into your property, they'll be difficult to exterminate. Steel doesn't have the same propensity as wood when it comes to termite damages. Since it's an alloy of iron, termites and other pests can't feed on it. With our high-quality paint coating, water won't decay the steel components. Unlike wood, it won't turn all spongy or soft when exposed to moisture. That makes our pre-engineered steel one of the best materials for your construction project, be it a steel workshop or a garage. By using steel, you can make your building less prone to pest infestations. Resilient and non-combustible. Steel's impressive resilience gives it the ability to withstand external shocks. Such shocks can result from earthquakes, blasts, hurricanes, and other natural disasters. Did you know there are approximately 5,000 small earthquakes in Canada every year? There are a number of high seismic locations in Canada, particularly the coast of British Columbia, the St. Lawrence River, and the Ottawa River Valley, to name a few. Our engineers specifically design our pre-engineered buildings to withstand earthquake forces outlined in the National Building Code. Also, steel is non-combustible. It also doesn't melt at the typical temperatures that structural fires often create. Since it doesn't burn or melt, it won't provide a source of ignition, nor would it serve as a fuel load. With that said, if a fire does start in a pre-engineered steel building, the structure won't contribute to its spread. It can also act as a barrier for fires, or at the very least, slow the flame's transfer rate. We also offer firewall or fire barrier designs. Lower associated costs. Our Canadian factory manufactures all the prefabricated steel components and ships complete buildings to any job site in Canada. As such, the materials come from a facility specifically designed for pre-engineered steel production. Since you can get them in fabricated form, buying steel will reduce on-site labor because our kits come ready to bolt together. In addition, getting prefab steel helps reduce construction waste. With fewer waste materials on site, there would also be less cleanup to do. Furthermore, there are steel building accessories designed with energy efficiency in mind. Insulation and roll-up doors, for instance, help prevent energy losses and gains. All of these then contribute to lower overhead building expenditures. Besides, the durability itself of steel means you won't need to replace them in just a few short years. Green and sustainable. Steel isn't something made for consumption, only utilization. Once produced, you can use it over and over again, whether as is or in a repurposed form. This alloy is the only true cradle-to-grave to cradle type of recycled material. Steel is 100% recyclable. No matter how many times it goes through recycling, it won't suffer from integrity loss. Meaning, you can recycle old steel beams and turn them into new steel beams. All this makes it one of the world's most sustainable building components. There you have it. 5 of the primary advantages for the benefits of steel for buildings. As you can see, it's no doubt one of, if not the best material for constructing structures. With this material, you can enjoy a building that lasts for decades, and if properly cared for, even 100 years. Ready to get that steel building up and ready for occupancy or use as soon as possible? We here at Global Steel Buildings can.
So that's it for the properties of steel. And for presenting the next part of this report, here is Mr. Jaire Iverson Gallo.
Good day, I am Jare Iverson Zigalo and I will discuss the uses of steel, the benefits of steel, and the different structural steel sections. So first, construction is one of the most important steel using industries, accounting for more than 50% of world steel demand. So makikita tayo sa mga construction industries ay kalimitang bakal din ang ginagamit for framework, sa paggawa ng beams, sa columns, at sa marami pang iba. Bakit nga ba ginagamit ng mga steel? Dahil yung steel ay affordable. And also, it is readily available and much safer. And meron siyang mga intrinsic properties such as the strength, versatility, durability, and 100% recyclable din siya, allowing for improved environmental performance across the entire life cycle of buildings. So yung mga advanced high-strength steels na ginagamit natin sa mga construction, ay ginagamit din naman natin siya sa mga iba't ibang mga industries such as sa paggawa ng or sa mga oil rigs, paggawa ng bridges, sa field din ng civil engineering at marami pang iba. So, sa report na ito, makikita natin yung mga iba't ibang application ng steel sa buildings at sa infrastructures. First, sa buildings, structural sections, this provide a strong stiff frame for the building and makes up 25% of steel used in the buildings. So, sa mga structural sections, ginagamit natin siya sa paggawa ng framework muna ng mga buildings. Yung mga beams, mga columns, mga purlins, mga steel din yung ginagamit natin dyan. Next, reinforcing bars. Yung mga bakal na ginagamit. These add tensile strength and stiffness to concrete and makes up 44% of steel used in buildings. Steel is used because it binds well to concrete and has a similar thermal expansion coefficient and is strong and relatively cost-effective. So, bakit nga ba sinabi dito na steel binds well to concrete? Kasi, yung steel and concrete has the same thermal expansion coefficient. In other words, kapag nagbabago ng temperature, nagbabago ng panahon, yung steel and concrete ay nagko-contract and nag-expand at nearly at the same rate. Pareha sila nagko-contract and nag-expand. At magandang senyales ito sa structural integrity ng isang building or infrastructure. Next is the reinforced concrete na ginagamit din natin siya for the deep foundation and basements and is currently the world's primary building material. Siyempre sa paggawa ng pundasyon ng bahay, kailangan mo ng steel din, tsaka ng concrete para maging maganda yung strength, maganda yung bigat na madadala niya throughout the layout or the framework ng building. Next, the sheet products. 31% is in sheet products such as roofing, purlins, internal wall ceilings, cladding, and insulating panels for exterior walls. So, mga sheet products na ito yung mga exterior walls or exterior na ginagamit natin sa mga buildings natin. So, sa purlins, steel din yung ginagamit natin for roofing. And yung cladding, ito yung ginagamit natin sa mga walls or nilalagay siya kasama nung paggawa ng mga walls para makapag-prevent ng noise reduction inside and outside the building. At yung mga insulating panels din ay ginagamitan din natin siya ng steel sheet for exterior walls. Next, non-structural steel. Steel is also found in many non-structural applications in buildings such as heating and cooling equipment and interior ducting. So itong mga non-structural steel na ito yung mga steel na hindi siya nakapasa dun sa certain test na ginagamit para maging structural steel yung isang steel. So, hindi lahat ng ginagamit sa construction ay purely structural steel. So, meron din siyang mga non-structural steel na nakapag-provide din ng heating and cooling equipment sa interior ducting ng buildings. And also, ginagamit din yung steel sa mga internal fixtures such as mga hanging mirrors or mga internal or steel type furnitures and appliances, or simply the freestanding furnitures and appliances. And also the rails and the stairs ay gawa din sa steel. Sa infrastructure naman, ginagamit natin ang steel sa mga tunnels, sa mga bridges, sa mga rail track. And about 60% of steel used in this application is as rebar, and the rest is sections, plates, and rail track. Sa mga rail track, halos steel yung ginagamit natin dyan. Dahil maganda yung strength and durability ng steel. At makakapag-withstand siya sa mga certain climates, and kaya niyang kukunin yung mga loads na ine-exert ng mga ibang mga objects. And also, steel is used for utilities. Over 50% of steel used for this application is in underground pipelines to distribute water from housing and to distribute gas. The rest is mainly rebar for power stations and pumping houses. So, itong steel na ito, ginagamit siya sa mga underground pipelines. So, usually ginagamit na type ng steel dito ay high alloy steels, na preferred din siya sa mga piping industry. Dahil ito ay merong property na toughness, and nakapag-withstand din siya sa ibang mga climates na dumaan, dahil yung mga climates nakakapag-cause din siya ng corrosion Although nagkakaroon din siya ng some corrosion, pero meron tayong mga corrosion inhibitors na nilalagay dun sa mga pipelines, steel pipelines, para hindi siya mangalawang. And dito tayo sa types ng structural steel section. So first, ayan, sa S-shape. So usually itong mga steel section na ito, mga beam na ito, ay kalimitan nating nakikita sa sa mga beams and columns. And also kung na-discuss natin ito or na daanan natin ito sa ating statics, ay ginagamit din itong pang-compute sa centroids and moment of inertia, itong mga steel section, yung mga channels na ito. So first is the American Standard Beam or the S-shape. Generally known as the S-beam, the American Standard Beam has a rolled section with two parallel flanges. Two parallel flanges, ito yung horizontal sa taas at sa baba, all connected by a web na nasa gitna. The flanges on the S-shaped beams are relatively narrow. So yung designation na ito gives the builders information about each unit's width and weight. For example, S12 times 50. So ano bang ibig sabihin nitong S12 by 50? So it represents a beam that's 12 inches deep and weighs 50 pounds per foot. So meron tayong makikita dito na S, di ba? S12 by 50. Yung S dito, ito yung shape ng beam. So meron tayong S shape, meron tayong H shape, may I shape, may T shape. Yan, depende sa shape doon. Yun yung designation niya sa S. So yung 12 naman, ito yung depth ng channel in inches. And yung 50 naman, ito yung bigat ng channel in pounds per foot. So, ganun yung pag-distinguish ng mga designation dito sa steel section. Next naman, angle L-shape. So, itong L-shape yung makikita nyo dito. Ayan. Pa-letter L yung structure nitong angle. So, angle beams take an L-shape with the two legs that come together at 90-degree angle. So, itong mga beams na ito or angle beams na ito are unequal or unequal leg sizes. Depende pa rin yan. Merong one leg na 2 by 2 by 0.5 at merong namang unequal leg na may size na 6 by 3 by 0.5. So, itong mga angle shape or L-shape beams ay ginagamit sa mga floor systems dahil ito ay nakapag-reduce ng mga structural depth. Bearing pile or H-shape. So when builders can find a structure on a shallow foundation, they use a bearing pile to design a deep foundation system. Bearing piles are H-shaped to effectively transfer loads through the pile to the tip. Bearing piles work best in dense soils that offer most resistance at the tip. Individual piles can bear more 1,000 tons of weight. So itong mga S-shaped pile or bearing pile ay mga structural beams. Usually ito ay dimensionally square at ginagamit siya sa mga soils para sa deep foundation application para maging suporta siya sa mga large buildings and bridges. Next is the channel or the C-shape. So itong C-channel na to ay C-beam, have a C-shaped cross-section. Yan, makikita nyo sa picture. Na meron siyang web connecting them and meron siyang top and bottom flanges. So itong C-shape na ito ay ginagamit from or for short to medium span structures. And usually ito ay naka-design for bridges at ginagamit din siya sa mga marine piers and other building applications. Also, yung C-shape na ito or yung channel na ito ay ginagamit din siya sa mga purlins, sa mga roofing na meron siyang C-shape kung makikita niyo sa mga trusses. Ito yung mga panlagay dun sa mga taas ng truss, yung mga purlins. Yung tawag dito ay C-purlin kasi may C-shape purlin siya. Next is the hollow steel section. Yan. HSS is a metal profile that is a hollow tubular cross-section. So, pwede siyang maging square, pwede siyang rectangular, pwede siyang circular, elliptical. So, ito ay rounded with radiuses that are twice the thickness of the wall. So, engineers use this kind of steel section para sa welded steel frames for each units experience loading in different directions. So, itong HSS na ito ay welded steel tubes na ginagamit for welded and bolted construction ng buildings or ng mga bridges at ng mga iba't ibang mga structure as well as a wide range of manufactured products. Next is the I-beam. So, kalimitan tatawag na H-beam din or the universal beam. Meron siyang dalawang horizontal elements, top and bottom, the flanges with a vertical element as the web. The web is capable of resisting shear forces, while the horizontal flanges resist most of the beam's bending movement. Then I-shape is very effective at carrying shear and bending loads in the web's plane. So itong I-beam na ito ay ginagamit siya kalimitan sa mga structural steel construction industry. At ginagamit siya pang support sa mga trusses or sa mga framework ng bahay, sa mga buildings din. And itong steel I-beams ay nakakapag-ensure na yung structure's integrity ay makakapag-provide ng relentless strength and support. Next is the pipe. So pipe are important for a variety of construction applications, lending in strength and stability. Pipes are hollow cylindrical tubes that come in a variety of sizes. So, yan, sa pipe nakikita natin sa mga bahay, di ba? Usually, ginagamit natin ito sa mga drainage or para maging maganda yung daloy ng tubig, pasok ng tubig sa ating mga bahay. So, ito yung gamit ng pipe. And next, for the T or the T-beam, ito ay isang load-bearing beam with a T-shaped cross-section. The top of this cross-section is a flange with a vertical web below. T-beams can withstand large loads, but lack the bottom flange of the I-beam, giving it a disadvantage in some application. So, itong T-beam na ito ay ginagamit siya kalimitan pang support dun sa mga slab. At ito ay isang intermediate beams na nakapag-resist ng mga loads na kalimitan na nakikita sa mga slabs. And last is the custom shapes. Syempre, hindi lang yun yung mga nabanggit natin kanina, yung mga steel sections. Nowadays, meron na mga iba't ibang style or mga iba't ibang shapes yung mga steel section natin. So, meron na tayong mga round bar. Kung makikita nyo sa picture, mga square bar, meron na flat bar, ball plate. So, ito ay depende pa rin sa engineer kung paano ba yung gagamitin ito. Custom metal fabrication opens the door to a variety of special structural steel shapes for any type of the project. Using state-of-the-art tools and techniques such as water jet, laser, and plasma cutting, metal fabricators can sculpt steel into a myriad shapes for specific needs. And next, dito naman tayo sa benefits ng steel. So, benefits of steel. Steel is reusable and endlessly recyclable. Bakit nga ba recyclable itong steel na ito? Ang steel kasi ay magnetic. So, madali siyang mai-separate sa mga ibang mga metals. And also, unlike recycled paper or glass, which suffer from degradation kapag nire-recycle, yung steel ay hindi siya nawawala ng strength. Kaya naman di nawawala yung kanyang value. And that makes the steel to be a recyclable one. So, itong steel na to ay most recycled material sa mundo. And also, steel contains at least 25% of recycled steel and enables energy efficiency in buildings and construction projects. So, bakit nga ba energy efficient itong steel na ito? Ito kasing steel na ito ay maganda siyang insulator for heat and cold. As the temperatures are maintained in a structural steel building, it helps to save the energy used for heating or cooling the property. And also sa ating mga bahay, as heat radiates quickly from steel roofing, nakakapag-create siya ng cooler home environment sa loob ng bahay. Since kung meron tayong mga steel roofing, hindi papasok yung init sa loob ng bahay. Magbabounce back lang yun sa environment at makakapag-produce pa rin ng magandang daloy ng hangin dun sa ating mga interior rooms sa loob ng bahay. Next is steel is strong, requiring fewer beams and providing more usable open space. So, ito is sa mga advantage nito. Yung steel ay matibay. And yung steel kasi ay unti lang yung kanyang diameter. Over 15 meters lang yung kanyang sinasakop. So, kung 15 meters lang compared sa mga rolled beams na over 50 meters yung lapad niya. Syempre, yung steel makakapag-provide siya ng open space yung so magagamit mo yung ibang mga space na yon para makapag-distinguish ka kung saan dito yung gusto mo, may malawak na room or hindi. So, yun yung isa sa mga advantage din ng steel. Nakakapag-provide ng open space para sa building. And also, steel is light, requiring reduced foundation. So, ito kasing steel ay magaan lang. So, syempre sa construction, yung mga truck yung nagdadala sa mga steel dun sa pagtatayuan, di ba? So, kung magaan lang yung steel, syempre yung konsumo dun sa pagas ng sa truck ay unti lang din. Unti lang yung konsumo niya. So, less din yung maibibigay niya na or less yung expenses. And also, steel requiring reduced foundation. So, meron tayong mga tinatawag na steel pile foundations. Kunwari, ay ibig sabihin lang nito na yung mga steel na nakapile lang sa isang mga sulok. And itong mga steel pile na ito ay madali lang din siyang tanggalin or madali lang siyang i-recycle. At pwede siyang magamit sa katapusan ng buhay ng isang building, leaving no waste material on site. Next, steel is less material implies resource saving and lesser impact on the environment. Steel's ability to maximize space and internal width with the thinnest shell possible means thinner, smaller structural elements are achievable. Since yung mga example, yung steel I-beam, yung lalim yun ay around half lang ng mga timber beams. Kaya naman nakakapag-offer yung mga steel I-beams ng greater usable space and also less materials din and lower cost compared sa mga ibang mga materials. Another is dun sa mga wall thicknesses. Yung mga wall thicknesses can be thinner because of steel strength and excellent spanning capacity. So, ibig sabihin lang nito ay hindi ka na kailangan mag-build ng napaka-solid or napakalaking column para masabing matibay lang talaga yung pagkakagawa mo. So, with the use of steel, with the lesser diameter or lesser spacing, ay makakapag-provide ka rin ng more usable space and maganda rin yung pundasyon ng bahay mo kung gagamitin mo mga steel. And also, steel flexible in combination with other materials. And earthquake resistant din ito due to steel's ductility. Since yung steel natin ay ductile and flexible, it flexes under extreme loads rather than rushing and crumbling. Many of the beam to column connections in a steel building are designed principally to support the gravity loads, yet they also have a considerable capacity to resist the lateral loads caused by the wind and earthquakes. So it is isa sa mga advantage nitong steel that it is flexible and durable. And also ductile. And itong steel na ito ay fast on sign build for prefabricated buildings. So kung i-assemble mo yung steel, gagawa ka ng steel frame, ay mabilis mo lang din siyang maisa-setup. And also, kapag tatanggalin yung mga steel frame, ay it will take a matter of days lang rather than weeks, with a corresponding 20% to 40% reduction in construction time relative to on-site construction. Depende sa laki ng project mo. For single dwellings or more challenging sites, steel often allows less point of contact with the earth, reducing the amount of excavation required. And lastly, the steel is very durable. So, ito lang ang report ko for the uses, the benefits, and the different structural steel sections. For the next topic, which is the classifications and designations, here's Miss Jamvi Buklatin.
Greetings everyone, I'm Jambi Buklatin from BSc 3-1, the reporter of Classifications and Designations of Steel. Classifications and Designations. The following classifications and designations are used for the different structural shapes presented in this handbook. Nahahati sa 5 class ang steel. First is the built-up, which is then categorized by shape like wide flange, heavy column, and wide flange T. Next naman is the cold form plate and cold form light gauge. In this process, rolling or pressing thin gauges of steel sheets are done. Cold form steel are created by the working of thin steel sheets using stamping, rolling, or presses para ma-deform ang mga steel sheets at mag-create ng different shapes with different purposes. Ang example na nakalagay dito ay angle, channel, Stephen C, rectangular tube, square tube. Another one under this classification is rolled. Dito naman, ang roll forming of structural shapes ay nagpapass through sa rolling mill para ma-bend or ma-deform sa desired shape habang mini-maintain constant ang cross-section. Desired shapes like wide flange, S-shape, channel, structural T, angle, pipe standard, pipe extra strong, pipe double extra. And then last one is the metal leg, which is then categorized with shape, and under na shapes meron siyang SD and CD. Nakalagay din dito sa table na to yung mga designation nila for N. Makikita natin sa next slide kung ano yung mga meaning na nakalagay sa mga designation. Where B is the flange width of the section, shorter leg of angles, shorter side of tubular sections in millimeter. Where C is the overall depth of lip of light gauge sections in millimeter. Where D is the depth of rolled sections in inches naman. Age is the depth of the section, longer leg of angles, longer side of tubular section in millimeter. N sub W is the overall width of metal decks in millimeter. T is the base metal thickness of the section in millimeter pa din. Where W is the nominal weight per unit length in kilogram per meter. Where yung small w is the nominal weight per unit length of rolled sections in pounds per feet. Fabricated shapes. The sections and shapes may be referred to as fabricated shapes as they are made from rolled flat products. Merong two general methods para makapag-produce ng structural shapes from flat steel. First is by welding, and second one is by cold forming plates, which is yung process na nabanggit ko kanina. Shapes produced by weldments ay tinatawag na build-up, yung natakal natin sa first slide na nakatable. Limited thickness ng steel plates ay greater than or equal to 6 mm. Shapes may also be cold formed by passing. By passing the flat steel products in rolls until the desired shape is attained, or by press brake bending. For consistency with common practice, however, the shapes are divided into two classes depending on the thickness of the base metal used. Yan. Ang una, ang cold form plate shapes ay gumagamit ng steel plates with thickness greater than or equal to 6 mm, while yung isa naman, yung cold formed light gauge shapes naman ay napoproduce mula sa coil, sheets or strips na may thickness less than or equal to 6 mm. So, yun yung pinagkaiba ng dalawa. Next is rolled shapes. Rolled shapes are defined here as those produced by passing red-hot blooms or blaze steel through rolls until the desired shape is attained. Except for the angles, the shapes and sections adopted are those from the ninth edition of the AISC Manual of Steel Construction. So here's a video on how rolled shape steels are made.
Rotating rolls reduce the thickness of the material and produce long strips that can be used for manufacturing products such as steel plates. We will be going through the various stages of the hot rolling process. Each stage requires knowledge and experience to ensure a high-quality product. The material is heated in the reheating furnace, rolled in the roughing mill, coil boxed, rolled in a finishing mill, cooled and coiled. Before the slab can be processed, it must be heated. The slab is continuously cast and has the dimensions required for the final product of a correct weight, width, and thickness. These furnaces heat the material to about 1200 degrees centigrade. Two walking beam furnaces feed the material through the oven. The heating is especially important as it affects the properties of the material. If the material is not sufficiently heated, incorrect material properties will arise. This is due to carbides and nitrates failing to dissolve. During the heating process and the transport to the roughing mill, the hot material reacts to the oxygen in the air, and a mill scale consisting of oxide is formed on the surface. If the oxide layer remains on the material during rolling, the layer risks being rolled into the steel material. A adversely affecting the surface quality of the final product. The material must undergo a mill-scale cleansing before rolling. In order to cleanse the surface, water is sprayed at high pressure, 160 bar. After the material has undergone a surface cleansing, it's sent to the roughing mill. Here, the material is rolled from its original thickness of 22 centimeters down to about 3 centimeters. This is a very significant reduction. At this roughing mill, a powerful 4-high rolling mill is used. That is, 2 backup rolls and 2 smaller working rolls. The backup rolls are often cast steel rolls. The working rolls must have very smooth surfaces and tolerate high temperatures and wear, as they are in direct contact with the material. This particular material is rolled with 5 passes, where 1 pass means that the material passes through the rolls once. The material is surface cleansed several times during the roughing mill process to remove any new traces of mill scale. In order to control the width of the material, vertical rolls are used. The material is now called transfer bars. After the roughing mill, the transfer bar is rolled up in a coil box. The coil box's primary purpose is to save space, but when inside the coil box, a temperature equalization also occurs. The temperature difference between the ends of the material is minimized as the transfer bar is coiled together. When the transfer bar is removed from the coil box, it has a temperature of about 1050 degrees centigrade. The ends of the transfer bar are cut off and the bar undergoes further mill scale removal. After this, it's time for the next stage, the finishing mill. This mill consists of 6 stands in the shape of 4 high rolling mills. Here, the transfer bars, now called strips, are rolled into a thickness of between 16 and 1.8 millimeters. Between the rolls, we see an uplooper, which measures and controls, amongst other things, the line speed and the strip tension. The swinging motion that can be observed is when the uplooper is adjusting itself. In order to control the profile and the flatness of the strips, the working rolls are horizontally adjustable. The first stands control the profile, and in the later stands, the flatness is controlled. It's very important to have a correct strip profile and flatness before any post-processing starts. The cooling rate is adapted to each strip to produce the appropriate microstructure and material properties of the end product. When the strip is passed through the cooling section, it's coiled in. The temperature during coiling varies between 150 and 750 degrees centigrade, depending on the properties assigned to the material. After coiling and the subsequent cooling, the strip can be sold directly to the customer or undergo additional processing stages, for instance, cold rolling.
Next one is the section and properties. The sectional properties tabulated were calculated based on generally accepted engineering principles and were generated using microcomputers. In calculating the theoretical weight of the steel sections, a mass density of 7,850 kilograms per meter was used. Workmanship and tolerances. The dimensions and properties shown on the tables are theoretical values, and those of the finished products will be subjected to the usual variations. tolerances not covered shall be based on applicable specifications relating to each class and shall be specified by the designer with proper regard to fabrication and erection requirements. Sinasabi lang dito yung mga finished product ng iba't ibang variations ng steel ay based lang sa theoretical values sa table na na-discuss sa first slide. Steel flat products. Flat structural steel products are locally available as hot rolled plates, coils, and sheets. So, dun nga sa napanood nating video, after nila gawin, pwede na silang ibenta. In addition, cold rolled coils and sheets are also manufactured locally. Next is utilizations of steel. Steel is environment friendly and sustainable. It possesses great durability. So aside sa di siya harmful sa environment, matibay din siya. Next is compared to other materials, steel requires a low amount of energy to produce lightweight steel construction. So compared nga sa ibang materials, ang nire-require lang ng steel ay low amount ng energy para makapag-produce ng mga lightweight steel. Steel is the world's most recycled material which can be recycled very easily. Its unique magnetic properties make it an easy material to recover from stream to be recycled. Steel daw is recyclable. Steel can be designed into various forms. It gives a better shape and edge than iron, which is used to make weapons. So, madaming pwedeng products ang magawa nga out of steel. So, isa yan sa mga utilization niya. Next is engineering steels are used for general engineering and manufacturing sections. Next utilization, steel is highly used in the automobile industry. Different types of steels are used in a car body, doors, engine, suspension, and interior. Sabi dito, almost 50% daw ng car ay made of steel. Next is, steel reduces the carbon dioxide emissions. Kaya nga siya, hindi siya masyadong harmful sa environment. Next, utilization. All types of energy sectors demand steel for infrastructure and resource extraction. So, in demand ang mga steel sa mga energy sectors for infra and resource extraction. Next one is stainless steels are used to produce offshore platforms and pipelines. Yan. Next is steels are used for packaging and protecting goods from water, air, and light exposure. So, nagagamit din daw ang steel sa mga packaging because of its ability to protect goods from water, air, and light exposure. Next utilization. Another one, stainless steel gives a hygienic environment. That's why it is used for surgical implants. So, ang steel din daw ay malaking tulong, lalo na sa medical field, kasi nga nagagamit siya for surgical implants. Makikita natin din siya sa mga sa dental implants karaniwan. Next is steel has a wider range of temperature which is used to make large sheets. Next one, renewable energy resources like solar, hydro, and wind power use the stainless steel components. Last one, mild steel is used for building construction. It is also a highly favored building frame material. So, and that's all for the part of my report. The next reporter for our presentation is Alano Vride.
Let's now talk about the ASTM standard tests for steel. But before we go to the said topic, let me just tell you what ASTM is. The ASTM or ASTM International stands for American Society for Testing and Materials. It is a developer of international voluntary consensus standards. ASTM standards are developed by committees of relevant industry professionals who meet regularly in an open and transparent process to deliver standards, test methods, specifications, guides, and practices. And since we now know what ASTM is and what it does, let's now discuss the standard tests for steel. Let's start off the ASTM A36. ASTM A36 is a standard material specification for carbon steel shapes, plates, and bars of structural quality for use in riveted, bolted, or welded construction of bridges and buildings, and for general structural purposes. This specification covers chemical and mechanical and other supplementary requirements for carbon steel bars, plates, and other structural plates. Here is a video for us to watch to know how strong an A36 steel when it met the standard test.
Hi, I'm Jason Jackson from Metal Supermarkets, and in this grade guide series, we're going to take a quick look at some of the more commonly used metal grades. In today's video, we'll talk about A36 steel. A36 steel is a low carbon steel, which means it has less than 0.3% carbon by weight. This makes A36 steel easy to machine, form, and weld, which is why it is one of the most commonly used hot rolled steels available. Due to the hot roll process, the surface of A36 is rougher than cold drawn products. In addition to iron, A36 steel typically contains 1.03% manganese, 0.28% silicon, and 0.20% copper, along with some phosphorus and sulfur. While most AISI grades are designated based on their chemical composition, A36 is actually designated by its mechanical properties. This means that A36 must meet certain mechanical standards, such as having a minimum yield strength of 36,000 psi. Here you can see some of the other mechanical properties of A36 steel, including a minimum tensile strength of at least 58,000 psi. The relatively low cost and good mechanical properties of A36 steel make it one of the most commonly used steels, particularly for structural applications. Bridges and buildings are often constructed of A36 steel because of its high strength and toughness. A36 is also commonly used in the automotive industry, general fabrication, and much more. Hopefully this video has given you a little more insight into ASTM A36 steel. If you need A36 steel for your next project, Metal Supermarkets is the world's largest supplier of small quantity metals, carrying over 8,000 types, shapes, and grades of metal, cut to size and ready fast. Don't forget to like this video and subscribe to our channel for more videos just like this.
Here are some pertinent or related specifications to ASTM A36. First is ASTM A307 Grade A for bolts. It is a standard material specification for medium-strength carbon steel fasteners, especially bolts, studs, or threaded rods for general purposes applications. Grade A is a heat-treated carbon steel bolting material within minimum tensile requirement of 60 ksi and hardness range from 121 to 241 bhn. Next is ASTM A325 Type 1 for high-strength bolts. ASTM A325 Type 1 is a standard material specification for high-strength carbon steel fasteners for use in high tensile structure bolting and other general purposes applications. Type 1 is a quenched and tempered carbon steel, alloy steel, or boron steel bolting material with minimum tensile requirement of 105 ksi, yield of 81 ksi, and maximum hardness requirement of 34 HRC. This specification is used for manufacturing heavy profile bolts, screws, stud bolts, threaded rods, anchor bolts, and other externally threaded fasteners. A325 specification covers requirements for chemical compositions, mechanical properties, hardness, heat treatment, recommended nuts washers for Type 1 fasteners. Next is Astm A563 for nuts. This Astm has different specifications or grades that varies on the size, hardness, etc. We could easily know the grade and the material type of the nut through the markings. If the nut has no marking, it could be specified as grade O, grade A, or grade B. This kind of nut is usually made of the typical carbon steel. On the other hand, if the nut has a marking of 3 curved lines, its specification falls under the grade C. It is made of carbon steel that may be quenched or tempered. When nut has a marking that is the same of grade C but with 3 on it, it falls under the specification of grade C3. It is made of atmospheric corrosion resistant steel and may be quenched and tempered. Another marking that can be seen on a nut is a capital letter D. This falls under the specification of grade D. It is made of carbon steel, may be quenched and tempered as well. Another one is the DH mark. This falls under the specification of grade DH. It is made of carbon steel, quenched and tempered. The last marking is DH3. It is graded as DH3. It is made of atmospheric corrosion resistant steel, quenched and tempered. Basically, they are made of the same material, which is the carbon steel, but they are treated differently. The main difference of them is the size and the load that they can carry. The fourth related specification to Astm A36 is Astm F1554 for anchor bolts. This specification covers straight and bent, headed and headless, carbon, carbon boron, alloy, or high-strength, low-alloy steel anchor bolts, also known as anchor rods. The anchor bolts are furnished in 3 strength grades, which are grade 36, grade 55, and grade 105. Grade 36 is a steel anchor bolts that is low in carbon and has a yield strength of 36 ksi. Grade 55 is a high-strength, low-alloy steel anchor bolts and has a 55 ksi yield strength. Last is grade 105. It is a high-strength alloy and steel anchor bolts that is heat-treated and has a 105 ksi yield strength. Last for the related specification is Astm A572 for rivets. This specification covers 3 grades of steel rivets in diameters from 1/2 to 1 1/2 inches or 13 to 38 millimeters for structural fabricating purposes. Grade 1 is a carbon steel rivet for general purposes. Grade 2 is a carbon manganese steel rivet suitable with proper riveting technique for use with high-strength carbon and high-strength low-alloy structural steel. Lastly is grade 3. It is similar to grade 2 with enhanced atmospheric corrosion resistance approximately 4 times that of carbon steel without copper. Second standard test for steel is Astm A955 or A955M. Astm A955 or A955M is a standard specification for deformed and plain stainless steel bars for concrete reinforcement is the main standard for stainless steel rebar in the USA and Canada. The dimensional bar profiles and grid structure follow their respective carbon steel standards. So, why is it important that the stainless steel rebars meet the requirement of this test? It is important because stainless steel rebar substitutes stainless steel for carbon steel in use as a concrete reinforcement material for applications where high corrosion resistance is desired or for critical components of the structure. Corrosion of carbon steel typically results from combination of carbonization of the concrete and chloride diffusion, where chlorides penetrate the concrete as a result of using de-icing agents such as chloride-based salts or from exposure to seawater splash. The reaction of the corrosive elements on the steel causes the formation of rusts, which expands in volumes up to 6 to 7 times that of the original metal. This expansion process generates forces that can lead to cracking, spalling, and in some cases potential structure failure of the concrete. The corrosion-resistant properties of stainless steel eliminate these mechanisms. Stainless steel is highly resistant to the effect of corrosion from the chloride penetration and is not dependent on the high alkalinity of concrete to afford protection to the steel. While there is a higher initial cost to its use, total life cycle costs for the construction project over its service period may be reduced when the high costs of repair and maintenance are considered for the alternatives. The third standard test for steel is Astm A500. Astm A500 is a standard specification for cold-formed welded and seamless carbon steel structural tubing in rounds and shapes. This specification covers cold-formed steel round, square, rectangular, or special shape structural tubing for welded, riveted, or bolted construction for bridges and buildings, and for general structural purposes. 4 grades are produced, each having different chemistry and tensile requirements. This tubing shall be produced in both welded and seamless sizes and must have the chemical requirements of carbon, manganese, phosphorus, sulfur, and copper. The steel shall be produced by either open hearth, basic oxygen, or electric furnace melting process. When steels of different grades are sequentially strand cast, the steel producer shall identify the resultant transition material and remove it using an established procedure that positively separates the grades. The tubing shall then be made by seamless and welding process. Welded tubing shall be made from flat-rolled steel by the electric resistance welding process. The longitudinal butt joint of welded tubing shall be welded across its thickness in such a manner that the structural design strength of the tubing section is assured. Tension test and flattening test should be conducted to the specimens. Anyway, I have here a video to further understand the tests.
Astm A500 is a standard specification published by the ASTM for cold-formed welded and seamless carbon steel structural tubing in round, square, and rectangular shapes. It is commonly specified in the USA for hollow structural sections, but the more stringent CSAG 40.21 is preferred in Canada. Another related standard is ASTM A501, which is a hot-formed version of this A500. ASTM A500 defines 4 grades of carbon steel based primarily on material strength. This is a standard set by the standards organization ASTM International, a voluntary standards development organization that sets technical standards for materials, products, systems, and services. Density: like other carbon steels, A500 and A501 steels have a specific gravity of approximately 7.85, and therefore a density of approximately 7850 kg per meter 3. Grades: A500 cold-formed tubing comes in 4 grades based on chemical composition, tensile strength, and heat treatment. The yield strength requirements are higher for square and rectangular than for round tubing. The minimum copper content is optional. Grade D must be heat-treated. References: ABA Astm A500 per A500 MO7. A500A Steel Material Properties, accessed October 8, 2006.
The fourth standard test for steel is Astm A572. Astm A572 is a standard specification for high-strength, low-alloy columbium vanadium structural steel for plates used in general construction and structural applications. Astm A572 includes 5 grades with specified minimum yield strength of 42, 50, 55, 60, and 65 KSI. Here is how they grade the said material. In terms of composition, grade 42 must be 0.21% carbon, 1.35% manganese, 0.030% phosphorus, as well as 0.030% sulfur, and 0.15 to 0.40% of silicon. While grade 50 must be 0.23% carbon, 1.35% of manganese, 0.030 of phosphorus, and 0.030 of sulfur, 0.15 to 0.40% of silicon. Grade 55 has to be of the same composition as grade 50, but the carbon content must be 0.25%. Same goes with grade 60. The only difference is that the carbon must be 0.26% and the silicon must be 0.40%. While in terms of mechanical properties, grade 42 has to have a yield point of 42 KSI, tensile strength of 60 KSI, and the minimum 8 inches elongation of 20%. Grade 50 must have 50, 65, and 18 respectively. On the other hand, grade 55 has to have a yield point of 55 KSI, tensile strength of 70 KSI, and the minimum 8 inches elongation of 17%. Last is for grade 60. Grade 60 has to have a yield point of 60 KSI, tensile strength of 75 KSI, and the minimum of 8 inches elongation of 16%. The fifth test is Astm A588. Astm A588 is a high-strength, low-alloy structural steel specification with improved atmospheric corrosion resistance for structural steel shapes such as angles, channel and beams, and as well as steel plate and bars. The A588 specification is intended primarily for use in welded bridges and other structures where savings in weight or added durability is important, along with a longer life cycle due to its corrosion-resistant properties. The sixth one is Astm A285. Astm A285 is a standard specification for pressure vessel plates, carbon steel, and low and intermediate tensile strength. This application covers carbon steel plates of low and intermediate tensile strength and is intended for fusion welded pressure vessels. The plates are available in 3 grades having different strength levels. For chemical composition, grade A must have 0.17% of carbon, 0.90% of manganese, 0.025% of phosphorus, and 0.025% of sulfur. Grade B must be composed of 0.22% of carbon, 0.9% of manganese, and 0.025% of phosphorus, as well as 0.025% of sulfur. And for the last grade, grade C. Grade C must be composed of 0.28% of carbon, and the rest of the elements must be equal to those of grades A and B. And for the mechanical properties, grade A must have a tensile strength of 45 to 65 KSI or 310 to 450 megapascals. Yield strength of 24 KSI or 165 megapascals, and minimum of 8 inches elongation of 27% and minimum of 2 inches elongation of 30%. On the other hand, grade B must have a tensile strength of 50 to 70 KSI or 345 to 485 megapascals. Yield strength of 27 KSI or 185 megapascals. Minimum 8 inches elongation of 25% and minimum 2 inches elongation of 28%. And last grade is grade C. Grade C must have a tensile strength of 55 to 75 KSI or 380 to 515 megapascals. Yield strength of 30 KSI or 205 megapascals. Minimum 8 inches elongation of 23% and minimum of 2 inches elongation of 27%. Seventh standard test for steel is ASTM A514. ASTM A514 is a standard specification for high yield strength, quenched, and tempered alloy steel plate, suitable for welding. This specification covers quenched and tempered alloy steel plates of structural quality intended primarily for use in welded bridge construction and other structures. Eighth standard test for steel is ASTM A516. ASTM A516 is a standard specification for pressure vessel plates, carbon steel, for moderate and lower temperature service. This specification covers carbon steel plates intended primarily for service in welded pressure vessels where improved notch toughness is important. The plates are available in 4 grades, each having different strength levels. Second to the last standard test is ASTM A6064. ASTM A6064 is a high-strength, low-alloy specification with improved atmospheric corrosion properties, covering hot and cold rolled steel sheet, strip, and coil intended for use in structural and miscellaneous purposes, where savings in weight and/or added durability is important. Last is ASTM A87165. This ASTM is a high-strength, low-alloy structural steel plate with improved atmospheric corrosion resistance. This specification provides for a 65 KSI minimum yield strength and an 80 KSI minimum tensile strength, plus the atmospheric corrosion resistance of this steel in most environments is substantially better than that of carbon steels with or without copper addition. That is all for our report. This is the list of our references where we got the information that we just discussed to you. This is for educational purposes and no copyright infringement intended. Thank you for listening.